The next question is question 1 C part. With a circuit diagram and waveform show how operational amplifier can work as a comparator. This is asked for 6 marks. Okay. So for 6 marks, first we have to give the diagram of the comparator. Okay. So using opamp. So you know that opamp has two input, that is your inverting terminal and non-inverting terminal. In the case of comparator, the opamp has no feedback, right? It works without feedback with giving by applying two inputs across one across your inverting terminal and the other across your non-inverting terminal. So V1 and V2 are the two inputs. So in this case, one of the main application is taken. V1 is taken as your DC and V2 is taken as your DC or your reference voltage, and V2 is taken as your AC voltage. Okay. So what will be the output? It will compare V1 and V2, and your output will be the comparison of your V1 and V2. Okay. So these are the important points which you have. So we will go on to the next diagram will be your waveforms. Okay. So circuit diagram and waveform. So how will you draw your waveform? You have to give the input waveform separately and the corresponding output waveform. So what will happen? So input waveform, I have taken it as a constant or your reference voltage, which is having a DC voltage of 1 volt. Okay. And this second waveform is your input voltage V2, which is nothing but your sinusoidal signal. Now here I have taken the same V1 as your dotted line, because the output, when you draw the output, you have to compare both the signals. See here. So this is dotted line is going to be your V1. So how your circuit works? So your circuit works in two cases. Case 1, so you can write all these important points. Okay, there is no feedback, the circuit uses maximum gain of an op-amp. So there are two important conditions. So in case 1, what you will be getting, the V out will be equal to plus VCC. So here you will be getting plus VCC minus VCC, supply will be given, right? So the output without feedback will be saturated to your plus VCC and minus VCC value. So V out will be equal to plus VCC. What will happen? It saturates to plus VCC whenever you have the input voltage of the non-inverting terminal greater than that of your inverting terminal. So when V2 is greater than your V1, your output will go to plus VSAT. Similarly, what will be your output? Output will be negative VSAT. The output will switch from positive VSAT to negative VSAT. Second condition, negative VSAT when you will get when your inverting terminal that is inverting terminal input is greater than that of your non-inverting terminal. Okay. So you will be, this is the second condition. When V1 is greater than V2, what you will be getting? Your output will be equal to minus VCC, which is nothing but equal to minus VSAT. So the same is given in this diagram. See here. So in this case, what is happening? Your sinusoidal voltage is less than that of your V1, right? So when V1 is greater, you will be having your output will be minus VSAT. So once your sinusoidal signal is greater than 1 volt, what will happen? It will switch to minus VSAT to plus VSAT. Okay. So that is how you are getting the output. So this is your corresponding output, input and output along with your circuit diagram and explanation, which will give you 6 marks.